Hi class, it's Professor Rourke. I wanted to make another video from one of the questions from one of the most recent sections that we had worked on, which was 3.6. And 3.6 was all about solving polynomial inequalities, which can often be this sort of labor-intensive type of problem. So this problem was 3.6 number 4, and it's also, if you see the label, it says B365 set up and solve. So whenever they're set up and solve, a lot of times they're sometimes the ones that can be some of the more frustrating ones because you don't really know what they're looking for. It's not necessarily just the answer. It's just supposed to kind of walk you along the process through the way. So that leads us to this problem. It says solve the polynomial inequality and graph the solution set on a number line, express the solution set in interval notation. So the polynomial inequality that they give us is x squared minus 13x plus 36. It's greater than 0. Okay, so first of all, before I read any further, let's just kind of think like, what do we know about everything that we just see here? We see x squared minus 13x plus 36. First of all, what kind of function is that? That's a quadratic, right? And that we know that for these most quadratics, we're going to have two solutions. We could have some multiplicity involved where there's like one number two different times, right? But typically we have two solutions. We can try to factor it. We can try to use the quadratic formula if factoring doesn't work, right? And again, we're looking for where it's greater than or equal to 0. So that tells me that when I am after I have found my boundary points, I'm going to then pick test values inside of the intervals, and I'm looking for where it's greater than 0. Greater than 0 is another word for saying positive, right? So I'm looking for positive output in my intervals. So, yeah, now these problems are a lot. So first things first, it says, use the inequality in the form f of x is greater than 0 to write the open intervals determined by the boundary points as they appear from left to right on number line. Choose the sign that describes the function values of f of x for each of these intervals. Whew, I know that's very wordy. So what they want us to do first essentially is the first part of what you're like asked to do on the notes or the homework. It's first it will ask you for the boundary points. Okay, so if this wasn't set equal to 0, we would need to do that first, but it already is, so that's good. So we can go ahead and now find the boundary points by solving the equation x squared minus 13x plus 36 equals 0. But right now, we're just going to ignore the fact that it's an inequality. That'll come back later when we have to do the number line situation. Right now, we're just solving for the numbers where the sign might change, right? Because if we want to find the boundary points and then we have to test to see like in between with 2 points, is it maybe positive? Which one is it negative, right? Again, thinking back to what we know about quadratics, each of these polynomials could be a little bit different, but they're all going to be polynomials. X squared minus 13x plus 36, like in theory, we know-ish that this is a U-shaped parabola, right? I could go through the whole shebang and find the x-intercepts. I could find the y-intercept. I could find the axis of symmetry, right? I could do all of those things. But at the end of the day, you can even use your graphing calculator if you really wanted to. Since this is like a U-shaped, I believe what's going to happen is the graph is going to start by decreasing. It's going to pass through the x-axis. This is where it's going to become negative, right? And then it's going to reach the vertex, and then it'll turn back up. So it's going to be like a nice finely U-shape. And if I had to guess, there's probably going to be 2 points that I'm going to find as my boundary points. And then in theory, the test value work is what is happening and the points in between. So if I had to guess, again, I haven't done anything yet, but I'm assuming it's going to be positive, and it's going to be negative, and it's going to be positive again because it is U-shaped, right? But let's go through it and see if that kind of checks out for what's happening. Sometimes, you know, it's nice to have like sort of like a visual graph of what is happening can helps to determine and sort of get our bearings. Okay, so let's go back and take a look at x squared minus 13x plus 36. This is a quadratic. Let's see if it's factorable. So this is set up so that a is 1. So it's sort of like the reverse FOIL, slightly easier version of factoring. Two numbers that multiply together to be 36, and that to be negative 13. I think that'll be -9 and -4, right? So I'm going to rewrite this as x minus 9 times x minus 4 equals 0. And then if I set each of those equal to 0, I'll go ahead and have out 9 and 4. Okay, so thinking back again to like my random graph I had up here, that checks out, I think, of like mostly of what we were thinking of. So now what we are typically asked to do on the, like on a, if this is a written problem, is we would have a lovely little number line and we would put our two numbers here, 4 and 9. So the difference with this problem is they have this section where it says use inequality in the form f of x is greater than 0 to write the open intervals determined by the boundary points as they appear from left to right on a number line. Kind of confusing, right? So what they want you to do is just the same thing that we're doing in class, just kind of writing it in a slightly different form. All right, so if we have a number line of 4 to 9, we want to continue it all the way to the sides. So we would, in theory, think about this as a number line as going all the way from -infinity to 4, then 4 to 9, then 9 to infinity, right? So the first interval that they want us to write here would be referring to this section to the left of 4. Okay, so I think what they want us to do is -infinity, comma, 4 with the parenthesis. Okay, and then the next interval, I'll go ahead and fill the intervals in, and then we'll come back and deal with the signs, would be from 4 to 9, right? And then the last interval would be from 9 to infinity. So again, slightly different maybe than what we did when we were just coming up with the number line, but these would be the same intervals that we would need to know for when we were writing the solution. So just kind of having you think about how you'd write the interval before you actually get to the answer. Okay, now to find the sign, it looks like you can say positive or negative. So there's a few choices of how to do this, right? You can pick points inside of these intervals. So we can refer to that as test value work, right? So for instance, the interval from -infinity to 4, I know which one I want to go for that one because it's the best one in my opinion, 0. Okay, so if we plugged 0 into this original inequality where it's greater than 0, the 0 minus 0 plus 36, this is a positive 36, which is positive, right? So I'm going to go to the sign option for where it says interval and change the sign to positive. And then we would do this again, right? So we could plug in a number between 4 and 9. We can go 5, right? And this is again where you could put, depending on what works for you and your level of comfort, you could plug 5 in and say 5 squared minus 13 times 5 plus 36. That's great. You could also just go to y equals and put in x squared minus 13x plus 36 into y equals and then look at the table of values. It's totally up to you. But when we put in 5, we get out a negative number, okay? Doesn't even really matter what number it is, it just matters that it's negative, okay? And then last but not least, we can plug in a number between 9 and infinity. I'll go 10, okay? And again, it's totally up to you how you want to do this. You could do 10 squared, which is 100, minus 13 times 10, which is 130, plus 36. It comes out to be a positive number. I think it would just be like 6, positive 6. Okay, and so it doesn't even really matter what the sign is, just that it's positive. So they want us to fill in positive. Okay, so I hope that kind of made sense of how what they were looking for there in terms of the interval and how they wanted us to write that, which again is very similar to what we've been doing. It's just that they sort of had you write when we were picking test points, we just were like, oh, look to the right of 9 or the left of 4, what point would fit there? It's just writing the same thing that we were saying. Okay, last but not least, it says solve the inequality. What is the solution set? Select the correct choice below, and if necessary, fill in the answer box to complete your choice. So we go back again, and we're looking to remind ourselves, okay, we're looking for one what's going to be positive. So the numbers we plugged in that gave us positive outputs were 0 and 10. Those were inside of the interval from -infinity to 4, or from 9 to infinity. So that's going to be our solution set. Okay, so I hope that made sense of what they were looking for there. I know, again, sometimes the setup and solve ones can just sort of throw us off because we don't really know what exactly they're looking for. But I hope that made sense. Again, this was 3.6, number 4, and the polynomial inequalities always just are a bit much, I think, because not only do you have to solve it, that's a lot, but then we have to then think about the whole number line situation and picking points inside each of those intervals that we get from the boundary points. So keep me posted on whatever questions you have, and I look forward to hearing from you soon. Thanks. Bye.